Hello everyone. In the previous video we have seen deterministic finite state automata with an example, and in this video we are going to see about non-deterministic finite automata. Non-deterministic finite automata means it has the power to be in several states at once. So it is similar to DFA. It is also having 5 tupules that can be formally written as NFA n is equal to Q sigma delta Q naught F, where n represents n is the name of the DFA. Q represents finite set of states, sigma finite set of input symbols, Q naught is start state, and F is a set of final or accepting states. There is a difference in the delta only. So delta of Q comma A equals P1 P2 to Pk. So in deterministic finite state automata, delta of Q comma A is equal to one next state, that is P alone. So current state and input symbol from the current state, the DFA can have only one transition for the next state, but NFA can be in more than 0, 1 or more number of states. So delta of Q comma A from current state Q, and for the input symbol A, it can have any number of next state. Now we see an example for NFA. So construct NFA to accept the strings of zeros and ones that end with 0, 0. So our DFA should accept all binary strings ending with 0, 0. So last two symbols must be, the final symbols of the string must be 0, 0. It is preceded by any number of zeros and ones. So it may be 0, 1, 0, 1, anything. So 0, 1, 0, 1, 0, 0 means this string must be accepted by our DFA. 0, 1, 1, 0, 0, 1, 0, 0. These type of strings must be accepted by our NFA. And suppose the string ends with 0, 1 or some other 1, 1, some other input string, means it should be rejected by our NFA. So we have to construct NFA for this. So assume that Q naught is a start state. This is the transition diagram representation. So we are going to consider Q naught as the start state. So Q naught is indicated as a start state, and the final symbols are 0, 0, and it is preceded by any number of zeros and ones in all the cases. So for any number of 0 and 1, the state remains the same state. Next state is same state only. It will be in the same state. And for this symbol 0, input symbol 0, it goes to Q1. And for the final input symbol 0, it is entering into the final state Q2. So this is the NFA representation for the binary string ends with 0, 0. So for any number of 0, this transition is for any number of zeros and ones. And for the final 0, 0, it is reaching the final state. Here we can take 0, 1, 0, 1, 0, 0. And for the first 0, it may be in the same state, Q naught. And for the 1, again it may be in same state Q1. For the 0 also it may be in Q naught, 1, 0, 0. For all states it may be in Q naught. But this is not a final state. But in another case, for first 4 symbols it will be in Q naught, and for the fifth symbol 0 it is changing to Q1, and for the final symbol it is reaching Q2. So it is reaching Q2 in at least one case, means it is a non-deterministic finite state automata. So that this is a transition diagram representation. We can write another representation with a 5 tupule notation, that is NFA n is equal to set of states. So Q naught, Q1, Q2, input symbols 0 and 1, transition function delta. Q naught is a start state and Q2 is a final state. We can write the list of transitions similar to DFA. And transition table representation is also similar to DFA. Rows correspond to states, columns correspond to the input symbols 0 and 1. Here the states are Q0, Q1, Q2. Start status indicated by Q0, final status indicated by star, Q0 and 0. For the state, from state Q0 and the input 0, it has two transitions, Q0 and Q1. There are two next states, so it should be represented within by a set braces. Then Q0 comma 1. From state Q0, only one transition is there for the input symbol 1. So the next state is Q0. Even though it is a single single next state, it should be represented by a set brace. Then Q1 comma 0, it goes to Q2. From Q1, there is no transition for 1. It is represented by a empty set. In DFA, we have used hyphen, but here empty set. From Q2, no outgoing transitions are there. No transition for input symbol 0 and 1. Now we will construct a DFA for the same problem. That is, our DFA should accept all the strings ends with 0, 0. So it may be preceded by 1, 0, 1, any string, any number of zeros and ones. So consider Q0 as a start state for the DFA. From Q0, if 0 is the input symbol, then it should reach the state Q1. Because 0, 0 is also a correct input string because the string ends with 0, 0. So first, for a substring problem, or the string starts with some substring, ends with some substring, means we need to draw like this. First we have to draw that substring like this. So 0, 0. Then we have to draw the remaining transitions. So from Q0, if 0 is the input symbol, it goes to Q1. Then from Q1, for the next 0, it goes to Q2. And in other cases, we need to draw the remaining transitions. So in Q0, we have drawn transition for 0. Now consider 1. Suppose from the state Q0, initial state Q0, if 1 is the input symbol, then state remains a same state. It may be in the same state because we didn't recognize 0. Then suppose the next symbol is 0, it can be changed to, the state can be changed to Q1. In Q1, if the current input symbol is 0, then it goes to Q2. Suppose the next input symbol is 1. That is, after recognizing 1, 0, the next input symbol is 1 means, then again we need to recognize 2 more zeros to reach the final state. So state should be changed to the previous state. That is, after recognizing 0, after recognizing from the start state, we have already recognized 0. So after recognizing 0, if 1 is the input symbol, again we need to read 2 more zeros to reach the final state. So from Q1, if 1 is a transition, then it should reach the previous state, because again we need to read 2 more zeros for reaching the final state. So we have drawn 1 and 0 from Q0, 1 and 0 from Q1. Now we need to consider the 2 transitions from Q2. So in Q2, if 0 is the input symbol, so after recognizing 0, 0, we will be in state Q2. So after recognizing 0, 0, suppose next symbol is also 0, means we may be in the same state because the string ends with 0, 0 only. But in Q2, after recognizing 0, 0, next symbol is 1. That is, after recognizing 0, 0, the next symbol is 1, means again we need to wait for 2 more zeros to enter into the final state. So in Q2, if 1 is the input symbol, then the transition should go to Q0. So this is the DFA representation for the strings ends with 0, 0. In NFA, from state Q0 to transitions are possible for 0. So we have the simple NFA diagram, but in DFA this is not possible. So this is a DFA representation for all the binary strings end with 0, 0. Thank you.